Hello and welcome to another tutorial. We are going to continue on discussion of how to create objects using the new operator and then how to call the constructors to initialize an object. So here's the code for the point class. This class has two public fields or member variables of type int. It has one explicit constructor that takes two parameters a and b and just initializes the fields x and y, and these are non-static fields, so you can initialize them, access them, and initialize them in a constructor. And note that we're not using the this pointer, this.x or this.y. We could do that, but here, because the name of the parameters local variables in this constructor is not the same as the fields, you don't have to use the this pointer basically explicitly, because no shadowing happens, right? In the past lectures we saw that if the name of parameters of the constructor is the same as the name of the fields, then you cannot say, for example, x equals x, because both of them are going to be viewed as the local variables by the compiler. So you have to explicitly tell the compiler, hey, the one on the left hand side is the field of this class. That's why you have to use the this.x, this.y, right? This class contains a single constructor, and we saw that when you provide an explicit constructor, the compiler doesn't add the default no argument constructor. So if you want that to be back, you have to explicitly add it also public point round brackets with no arguments, etc. So if you don't provide any explicit constructor, the compiler will add the no-arg constructor in the bytecode. You don't see it in the source code, but it is in the bytecode, because every class has to have a constructor to be called, right? That's basically the idea. So even if in the source code there is no constructor, it means there is a no argument constructor, and then when you call the new operator, you can only call that no-arg constructor to basically construct the object, initialize it, and then get a pointer to it. The constructor in the point class takes two integer arguments as declared by the code int a, int b. The following statement provides 23 and 94 as values for those arguments. So again, assignment operator, the right hand side is going to be evaluated first, and then the result is going to be assigned to the left hand side. Every variable in Java has to have a type, and in this case, when we use the new operator, we are allocating memory on the Java heap, so we get a pointer back. Pointers are basically in Java, they are referred to as references, and references are handicapped pointers. You lose a lot of capabilities the raw pointers provide, but it makes your code safer and easier to work with. All right. So the new operator allocates the memory for the type. So you have to use the fully qualified name. We saw this in the previous lecture. I put a lot of emphasis on that. After the new, it's not the name of the constructor, it's the name of the type, and the name of the type is the fully qualified name. So again, I repeat this over and over again because other people don't talk about this kind of stuff. After the new, you have to tell JVM what type you want to initialize, and that's the name of the type, not the name of the constructor, right? And then the type means the fully qualified name. After that, you put a pair of round brackets and then some parameters, and based on the type of parameters, the JVM knows which constructor to call, and then based off the values, JVM initializes the state based on the code that you have in the constructor, in that particular constructor. The result of executing this statement can be illustrated in the next figure. So origin 1, this is our variable. Every variable has to be, and this is a local variable, so we have to create this new point something somewhere, probably in the main method or any other method. So this origin becomes a local variable on the stack frame of that particular method, and this is just a pointer. And then the actual memory for this object, basically this object holds some data as part of its state, and those data have to be stored somewhere in the memory, and they are stored in the Java heap. That's the meaning of the new operator. And this pointer is just pointing to probably the memory address, the first byte of the memory allocation for the state of this object, right? I mean, pictorially, you can just assume that there is a pointer pointing to this entire object. Basically, it's pointing to the state of the object. If you lose this pointer and nobody else is pointing to it, then this memory, this data is lost, right? This object and its state is lost. No one can reference it. No one can point to it, so you can never reach out to this object, to this data again, which means now these are occupying memory, but this data is garbage. Nobody else is going to use it, and that's the job of garbage collector, to behind the scenes run some extra code to clean up the memory, the garbage. Here is the code for rectangle class, which contains 4 constructors. Again, we are explicitly adding the no-arg constructor, and we can do some extra code like initializing the origin with something. And note that now this origin is a variable, is a field of this rectangle, but it's the type is another variable. And again, in order for this rectangle to be able to hold a variable of this particular type point, this type point has to be accessible to this class rectangle. And again, we talked about this when we talked about the access modifiers. When you declare a class, we said that a class in the source code can either have a public access modifier or no access modifier, which means it's either package level access or public to everyone. So before being able to create, even before this, because again, we are trying to also call the new on this constructor of this point. So these are 2 separate things. Again, I'm going to repeat this again. I mentioned this in the previous lectures, but let's repeat it one more time. In order for this rectangle to hold a field of name origin of this type point, this rectangle class must be able to access this type, must be able to access the type. So if this point class is defined in another package and it's not a public class definition, this rectangle cannot access this type. So you get a compilation error. So let's assume that now this point is either a public class or it's in the same package as rectangle. So this rectangle can hold a variable of this type because the type is accessible. But then in this constructor, the rectangle class wants to actually create a new instance of this type. So not only it has to be able to access the type, it should also be able to access the constructor. So if this particular constructor of the point is a private constructor or protected constructor, something that other classes cannot reach, cannot access, then you get a compilation error. So 2 separate things: accessing the type itself to be able to hold the field of that particular type, and then accessing the constructor to be able to actually create an object of that type, right? These are 2 separate things: accessing the type itself and accessing the constructors. Each constructor lets you provide initial values for the rectangle's origin, width, and height using both primitive and reference types. If a class has multiple constructors, they must have different signatures. Which means you can do constructor overloading, exactly like method overloading. All the rules that we discussed about method overloading also apply to constructor overloading. Note that when we talked about method overloading, we also briefly talked about another concept called method overriding, and that applies when you are into some sort of type hierarchy. You extend another class or you implement a interface, right? But you cannot override constructors. So constructor overriding doesn't have any meaning. You cannot do that because we know that if you extend another class in the constructor, the first line of code has to be a call to the superclass constructor, which means when you're trying to create an instance of the subclass, you have to guarantee that the state of the superclass is going to be initialized first, right? That's a guarantee that you have to provide. So constructor overriding doesn't have any meaning. It's not a correct terminology, and it doesn't have anything of use, right? If a class has multiple constructors, they must have different signatures. This is called the constructor overloading. The Java compiler differentiates the constructors based on the number and the type of the arguments. When the Java compiler encounters the following code, it knows to call the constructor in the rectangle class that requires a point argument followed by 2 integer numbers. And again, new operator, you have to tell what the fully qualified name of the type is, and then based on the type of the parameters, JVM knows which constructor to call. After the object, the memory on the Java heap is allocated and the memory is initialized, or the state of the object is initialized, JVM returns back a pointer to you. And this pointer is going to be stored on the stack frame of whatever method is this new statement inside of it. This calls one of the rectangle's constructors that initializes origin to origin 1, right? So we have this rectangle class hold a field that is of type reference, which means it's a type of another class point. So origin 1 basically is pointing to that, but then and know that we are passing an object which already we are passing a pointer or a reference to an object which was of type point, which we already created outside the rectangle, right? So origin 1 was pointing to that point object. This field origin inside this rectangle class also gets initialized with the same, again, pass by value. When we call the constructor, the value that this variable origin1 holds, and origin1 is a reference or a pointer, so its value, its hex value, the memory address that it holds, copies into this method. And obviously 100 to 100, these are already literals, so these are not variables. So origin gets a copy of the memory address that the origin1 holds, which means origin is also pointing to the same point, right? In general, this is not a good practice. Usually when we want to create a class, we don't want its state to depend on external classes, because if the state of this particular point is changed outside this rectangle class through origin1, then rectangle class immediately sees that change through the origin, right? Because origin and origin1 have the same memory address value, right? The value that they hold is the same memory address, or in other words, they're pointing to the same object in the memory. The following line of code calls the rectangle constructor that requires 2 integer arguments which provide the initial values of width and height. If you inspect the code within the constructor, you will see that it creates a new point object with whose x and y values are initialized to 0. So we have a constructor. Somebody provides a point, which means somebody else outside the rectangle class takes on the responsibility of creating a point and passing us a pointer to that point. So the assumption here is that whenever you have a parameter of some user-defined type of type that is not primitive, it means somebody else has to create it and pass it to this constructor or this method, right? This is sometimes called the dependency injection, which means this rectangle class doesn't own the responsibility of managing this type point. This type has been declared somewhere else, and somebody creates an instance or an object of this type, and they just pass a pointer to us, that pass a reference, and we just copy the reference, right? Obviously this is very cheap, because passing references or pointers is very cheap instead of passing the entire object. Again, this is something that you don't worry about in Java, because in Java there is no distinction between pass by value and pass by reference or pass by pointer. Everything is copied pass by value. Everything is allocated on the Java heap, and you never copy the entire object when you call a memory. You just copy the pointer or address type. It knows to call the constructor that requires so we saw this, and then if you call this constructor, then inside the code inside this constructor calls the constructor of the point and creates a new object. Now the rectangle class takes on the responsibility of managing this point, right? So nobody else provides the dependency, nobody injects the dependency, which is a point, which means nobody else has created a point somewhere else. So they just give us width and height, and then we create the dependency ourselves. Again, in a more professional term, origin of type point is a dependency, which means this type class rectangle depends on another type, because it holds a field that is of type, and this field can point to some object of type point that has some data state, right? So this rectangle class depends on this other type. And either somebody can inject this dependency into our class by creating the point first and then providing it to us, or we can do it ourselves, which means now we are managing our own dependency by explicitly constructing the point and not asking anybody else to provide it for us. So this is the concept of dependency injection in a brief discussion. The rectangle constructor also has a no-arg default constructor, and then all classes have at least one constructor. If a class does not explicitly declare any, the Java compiler automatically provides a no-argument constructor which is called the default constructor. This default constructor calls the class parent's no-argument constructor or the object constructor if the class has no other parent. So if you don't provide any constructor, the compiler provides the default no-arg constructor, and inside that it tries to call the superclass constructor, the constructor of the superclass that doesn't take any parameters, right? That's the only logical way that the compiler can implement it. And if your superclass doesn't have any no-arg constructor, then you are in trouble. So let's look at an example. Let's create a let's say we have let's see, this bicycle class has 2 constructors, right? And then let's create a class, let's call it let's see, I guess in the OOP we had this car class, and this car class doesn't have we didn't explicitly provide any constructor, right? Which means it gets the default no-arg constructor that the compiler provides, right? And then let's say we create a new call. Let's call it Tesla, and then we're going to inherit from the car, right? And then here we're just saying that we're not doing any. Let's have a main method, right? But we're not providing any constructor, which means it's basically compiler or Java C provides the no-arg constructor, which means the compiler provides this line of code, public Tesla, and then inside that there's going to be just a call to the super, whatever it is, and in this case this refers to car constructor, the one that does not, the constructor that doesn't take any parameter, constructor that does not take any parameters. And if superclass does not have a no-arg constructor, then we are in trouble, right? We get a compilation error. And when does a class when is it that a class doesn't get a no-arg constructor? If you explicitly provide a constructor. So here we can go and say let's say we go here after we declare the field. Let's say we declare the constructor public car and then int price, right? Something like that. Now if we do this, I get a compilation error here because I don't, as soon as we explicitly provide a constructor that doesn't take any that does take some parameters, we lose the no-arg constructor that the compiler implicitly provided for us. And the compilation error is basically is going to tell us the same thing. The constructor car is undefined. So the compiler is telling us, hey, you explicitly provided a constructor here which takes parameters, so I'm not going to provide behind the scenes, I'm not going to provide a no-arg constructor. If you want it back, you have to do it manually explicitly. So if you want the no-arg constructor back, you have to do it manually. You have to explicitly ask for it. Again, Java, everything is explicit as much as possible, just because that makes code safer and more readable and more reliable, right? Which means you have to do public car and nothing, right? You have to explicitly provide this, otherwise the compiler is not going to provide it for you. And let's say we go back and fix this by passing some number in. Now the compiler knows which constructor to call. There's only one constructor. But in the Tesla class, which is a subclass of car, now we are getting compilation error. Why? Because if I didn't provide any constructor for this Tesla class, which means the compiler is going to provide a no-arg constructor, and inside that it's going to call or try to call the constructor of the super class that doesn't take any parameters. So that's the assumption here, that the car is going to have a no-arg constructor. So if you don't provide any constructor for your child class and the superclass doesn't have a no-arg constructor, you get a compilation error, because whenever the compiler provides the no-arg constructor behind the scenes, the assumption is that it's going to try to call the constructor of the superclass that doesn't have any parameters. And obviously there are cases where the superclass doesn't have a no-arg constructor, then you get a compilation error. So let's look at the compilation error here. It says that implicit super constructor is undefined. So for the default constructor, it says that, okay, your Tesla class is getting a default constructor. The compiler is providing that. But then it's going to implicitly call, inside that default constructor, it's going to call a super class constructor which doesn't take any parameters. But car doesn't have that. So must define an explicit constructor. So basically the compiler is complaining that, hey, you can't have a no-arg constructor for Tesla because your super class doesn't have a no-arg constructor. So I don't know what to do. The only thing that they taught me, like the people who created the JVM, the only thing that they taught the compiler is that if the class doesn't have an explicit no-arg constructor, provide one, and inside that always try to call the no-arg constructor for a superclass. So what's the solution? The solution is that we should provide a constructor ourselves and explicitly call or initialize the state of the superclass via the constructor that takes some parameters, right? So let's say we want to have a default no-arg constructor, and we can initialize the state of the superclass by some value, let's say 10, right? So lesson to learn here is that if superclass doesn't have any no-arg constructor, then the subclass also cannot have no-arg constructor. No subclass can have a compiler generated no-arg constructor. So this is a limitation in Java, right? This is what Java enforces, Java compiler. Some people might argue that this is something unpleasant or annoying, but I believe that it's there for a good reason. It makes the code more explicit and more easily understandable. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.